Okay, so I'm gonna go over the activity at the bottom, but I just wanted to make sure that you have watched both these videos, that you're aware there's a web calculator. I'll be using that for part of this video. Be sure that you show your work is one of the things. And read the comments here. So basically all you're doing is taking sine of A equals h over c and isolating just the h. And I give you an example here. In the comments I can't insert equations, so it looks a little weird, but if area equals length times width, and you're asked to solve for W, all you would do is divide each side by L, so you have width equals A over L, or area over length. So it's the same idea over here. Once you've completed that, then all you're going to do is take this formula and replace the H with all of that. I should actually say, hold on, I wrote that back. So you're going to replace the H in this formula, substitute the H in the given formula in number 5 with so you're going to take the formula you find in number 4 and put it in this H right here, and that's that. I'm not going to go over this one too much. All you're going to do is take each one of these expressions, start by multiplying 2 over ABC, multiply it by this, and then also equals this. So you're going to multiply this part by 2 over ABC and this by 2 over ABC, and then simplify, and then you have the law of sines. And basically that is the law of sines there, and above here. Somewhere up here. Oh, here you go. So it can be written either way. It can be written this way, or it can be written this way. Doesn't matter. Okay, so let's take a quick look here. Alright, I have a whiteboard, and I will do my best to draw triangles. They will not come out fantastic, but because I'm just using my mouse. Boop, boop. So we have, let's move this over. Okay, so we have Z for zebra's house is this vertices, and then E, we're going to label all of them. And I think it goes like about so. It's not really to scale. We have G for giraffe is here, H for hippo here, and I believe the last one is the tiger. And we're given some values, and then we have to find the rest. We're given that this is 37. And we're given, whoops, wrong way. The segment ZG is 235. And we're given that the segment GE is 349. So you need to make sure you have this written down, because you are going to need to fill in. I'm going to get you started, but I'm not going to do the whole thing here. 465 is segment ET. And finally, angle HTE is 41. Okay, so there we go. So just to review, if I, oh shoot, can I do that? So, having issues, sorry. Actually, my mouse is harder than my finger here. All right, let's try it this way. Yeah, that's better. Kind of, excuse me, for the blue. I'll erase that. So this angle in blue would be ZEG or GEZ. Gosh, I'm having a hard time today. All right. There we go. So, first things first. We have the law of sines that we're going to use to find missing angles and sides. Not always. Sometimes we can use things like the sum of a triangle, the interior angle is equal 180. So let's look here. If we want to find, oops, excuse me. Maybe we want to find, where do we start? We'll start with, I think we'll start with ZEG. So this angle right here. So what we have is it's very important that you note that we're going to call this angle A, so that's a capital A. We'll call this B, and this angle C, because it's a whole lot easier than me saying ZEG over and over again. So if this is angle A, then this is side A for this triangle, and if this is angle B for this triangle, this is side B for the triangle, and if this is angle C, then we call this C. So we're going to use the law of sines to find angle C. When you're trying to find an angle rather than a side, it's a lot easier to start with the sine of the angle as the numerator, because remember I said you can write the law of sines either this way or this way. They're still the same, they're just flipped around, because as long as the numerators are consistent and the denominators are consistent, they're equal. So when you're trying to find an angle, use this one. When you're trying to find a side, use that one. So, let's go back. Where was I? There we go. So in this case, we're looking for the sine of C. So that's the unknown up here. But we do know that the side C is 235 feet. Is equal, that's a C, not a G, by the way, right here, is equal to, we've got A and side A. So we've got angle A, so the sine of 37 over 349. Because that's side A. Okay, now keep in mind that we want to isolate this right here. Sine of C is one thing, one number. It's not sine times C. It's just one thing. Because look, if I give you the sine of 37, it's a number. It's not, it equals this number. It's not sine times 37. Okay, I just want to point that out real quick. So, what I need to do is isolate this sine of C. So right now, sine of C is being divided by 235. So the inverse of division is to multiply, each side by 235. Alright, that's the inverse. And I'm going to multiply this whole thing by 235. So what I have, then I go to my calculator and I'm going to do the clear sine of, I already forgot, sine of 37 divided by, oh wait, actually, let's go back, sine of 37, and either you have to close the parentheses and then do divided by 235. side, not 235. 349. Equals that number times 235 is going to give you, let me make sure, so 405. The other way I could have done it is sine of 37 equals divided by 349 times 235, and I'll get the same number. So now what I have is this number point 405, so on and so forth. That does not mean the angle here, ZEG, which we're calling C, does not equal 405 thousandths. That's the sine of C. In order to find the angle, you need to go to the arc sine, inverse sine. So you hit second, and then see the ace. So before I hit second, you see sine and then the -1, which means like the inverse of sine. So you hit second, and you're going to hit arc sine. Now I'm putting in the value of the sine, which is 0.405 equals, and what I get is 23.9, blah, 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 blah. This is the angle, 23.9, but go ahead and round it to the nearest whole number. So let's look. What we found here is the angle here is 24. So that's the degrees. Gosh, sorry about that. There we go. So in here we found that GEZ, so you can either call it GEZ or ZEG. We found that GEZ was 24, which is what you got here, but this looks like a fraction. So if this is the number you rounded it to, just please put 24. Now, the next one is, you don't have to do it in this order, but it's easy. If you do EZG next, or sorry, ZGE next, because look, I have 37 plus 24 plus some number has to equal 180, because the interior angle of triangles has to equal 180. So I have 180 equals 37 plus 24 plus some number. So what do we have? We have 37 plus 24 equals 61, and we need to do, so now we have 180 minus 61 means that this angle here is equal to 119. Now, using the law of sines, we can find this length. But first, before we even do that, I'm going to do something even easier and go, look, this right here, they're supplementary angles. They have to equal 180. If this equals 119, what does this equal? The G, the EG, what is that? Hippo, that's an H, not a 4. EGH, what does that have to equal? Since they're supplementary angles, we know that they have to equal 180. So here it's easy enough. 180 minus 119 to get that. Now, since I found this and I've got 61 and 42, I can easily find this angle because I know that the sum of these three angles must equal 180, and then therefore I can find this angle because I know these two together must equal 180, and finally I can find this angle because I have this one, and this one must equal